好，那4点钟啊，大家差不多回来了。那金飞，我把时间交给你。金飞，会听到吗
在，还有白涛
？OK。
我看一下很厉的大家下午好哈我是思科中国区的D1产品经理哈，然后接下来呢，我们邀请到了韩丽的然后来给大家介绍一下在思科如何用自己的 ID1来管理思科在全球有7万多个员工然后在100多个国家480个 office 如何在疫情正在出现疫情，然后还有在现在这种远程办公或者是离线办公的时候情况下如何利用 ID1然后来帮助思科自己来保持业务的连续度那么后面就是请韩丽的然后来给大家介绍一下思科如何利用思科自己的 ID1当中一些场景和一些经验给大家做一个分享。韩丽there。
Hi,
Hello, everyone.
hello.
Hello, Halid.
Hi.
Yeah,
Okay.
I just make introduce about how Cisco leverage SD1 or ID1 to support around globally Cisco globally the across the different circuit and we have lots of the employee during pandemic. So could you please share the details how Cisco using the SD1 leverage SD1 to make the business keep the resilience?
Yes, absolutely. In fact, it's my pleasure to do that. So let me share my screen.
Sure.
Okay. If any partner have questions, just type your question in the chat box, and then we will translate. Maybe you can type Chinese and we can translate to the speaker, and then ask your questions. Yeah. Thank you.
Thanks, Ray.
All right. Thank you. Well, good afternoon, everyone. As Jennifer said, my name is Khalid. I am the lead SD-WAN design engineer in Cisco IT. And I am going to talk to you today about how we have deployed SD-WAN across all the Cisco sales offices globally. Can you see my share?
Sure. I can see it. Yeah. Sure.
Brilliant. Thank you.
Yeah.
Okay, this slide just talks very high level about the kind of numbers we see when we are talking about the Cisco enterprise network. As you can see, we are a large enterprise network, and which means, if you put us in the market verticals, then we sit in the large enterprise space. It is not very different from the large financial space where you have retail banking, but obviously our requirements are different in that sense. So we are a large enterprise. We have nearly 70,000 users across the Cisco offices, in campuses, and in sales offices. And the total user base is nearly about 133,000, which includes extranet partners. Again, these are numbers that we are just trying to show you that we have to support whenever we have to look at the branch office network. Just very high level numbers. And these numbers change, right? Sometimes we close offices. sometimes being open offices, but this is a rough estimate of the kind of things we have to deal with across our network. Okay, now when we look very high level at our global network, then we are present across 90 plus countries, right? So the way we build our backbone core network is we have got a hub in a region, and then in that region, all the branch offices which are in that region will terminate on that hub. And so like this, we have 17 hubs globally. Again, this number changes. Maybe we move out of a hub, maybe we increase a hub, but it is approximately 17 hubs globally. And in these 17 hubs, we have nearly 400 offices that connect at various locations around the world. Our primary method of connection is L2 VPN, so MPLS VPN, but layer 2. And then we also have, as a majority, we have internet circuits, which we call DIA. So in the next slides, I'm going to talk about the type of offices, and then I'll give you more details. But when you look at a hub, most of the branches in that hub will be connecting with the primary circuit as MPLS VPN layer 2, and with the backup being an internet circuit. Between the hubs, the connectivity is TDM or private line, whatever you want to call it. And it ranges anything from OC3 to all the way up to OC12 and 10 gig, depending on what kind of connectivity is required in the core. So mostly it is in the range of 10 gig to 1 gig, right? We are trying to move away from the channelized or the OC speeds. Okay, so in summary, we have 17 hubs across the globe, and we have 400 offices distributed that are aggregating into these hubs. Now, the last thing I want to share around the global network is that we also have 12 default routing domains. What this means is that if, for example, I am sitting in the United Kingdom, and if I go out through the internet from my office, then we have to follow the London default routing domain. That means we have an IPOP in London, and so I will go out of London. If I'm sitting in Dubai, then, or in somewhere in Africa or in Europe, except United Kingdom, then I will use my Amsterdam default routing. That just means my ISP connections are sitting in Amsterdam. So like this, we have got 12 default routing zones across the globe, which are used to provide internet access to corporate users who are going out to the internet. Okay. I think if there are any questions, Bill, like you said, please feel free to type them, and then we will have a question answer session towards the end of my slides. Okay, I am now moving to the different kinds of branch offices that we have. So this is our branch office catalog, if you want to call it. Now, if you look at this slide, you see 6 columns there. And if you focus towards the left, then you will see that as you move towards the left in this slide, then the criticality, the resiliency, the redundancy, the number of users increases. So on the left, we have the priority office platinum design, where we have the most critical of our business functions like TAC, contact center, IT data centers, large campuses. And so these kinds of offices are normally serviced by dual high-speed links, and they have both local diversity in terms of service provider access. They also have N+1 redundancy in everything that is offering access to the employees working in these locations. Then as you move towards the right in this slide, you go to the gold design, you go to the silver design, and you go to the bronze, and as finally you go to mobile VPN, which is the least. Now, the target sites for SD-WAN for us right now are the gold and silver sites. So when I talk about gold site, a gold site is something which has got 2 WAN gateways. It has got the primary link as MPLS layer 2 VPN, like I told you. It has a backup link, which is internet-based, so it's DIA. Now, while I'm talking about the DIA link, I'll tell you what kind of interlink link we use on these offices. We don't use XDSL. We don't use cable modem. What we use is a dedicated last mile Ethernet handoff from a tier 1 service provider. So our last mile is not shared, as is the case in cable modem or in broadband. So there is an important lesson in this, which I will come to later. That is why I am explaining in more detail about what type of internet connection or DIA connection we have on a gold branch or on a silver branch office. Okay. So in the gold design, just to recap, we have dual WAN links, one L2 VPN, one DIA, and then we have redundant devices. We have 2 ISR 4451 WAN gateways. We have 2 Catalyst 9000 switches. We have 2 WLCs. We have everything 2 in pairs below the WAN gateways. Then when you move to the silver design, now we don't have redundancy. We have a single DIA link, we have a single WAN gateway, and we have a single switch stack below that, which means that this is a non-critical office, right? Whereas the gold one is a critical office which requires a redundancy. And now as you go further to the last 3 columns, then there is the bronze design. The bronze design is typically similar to a silver design, with the exception that this we do not have any switch stack below it. This is most likely a single device provision in a shared office space, managed office space, where you will use the landlord's internet in that building or a shared internet in that building to provision wireless access mainly to your employees who may come and go in a virtual office there. And then finally, we have home office, which is CVO, and then mobile VPN. So this is a very high-level overview of the different kind of offices that Cisco has in the field. So why did we want to go to SD-WAN?
Khalid, I got 2 questions about your previous page. Could you please go back? Yes. The one is, could you give us the number about the silver design? How many people will using the small office? Average. Just to give us a number for reference. And another question is about the we know Cisco has Cisco Tech, which is a call center. We're serving all of our customer around the world. So so if the tech or for example, if the tech center, which level, which design it should be belong to, gold or silver?
Okay, thank you. So I have 2 questions. The first question is roughly how many users sit in a silver design. So let me answer that first. In a silver design, we typically have 25 plus users, but users is not the only criteria for making a office silver. If we have customer visits there, so maybe we have a customer experience room over there, then also it becomes a silver. If we have to put there a lab for the local system engineers to do whatever they want with lab equipment, then also it becomes a silver. So yeah, there's some other criteria also that defines whether a site is silver.
Makes sense.
Okay, now I'll go to the next question, which is where do we place TAC? TAC is always placed in a platinum office.
Okay.
If we, and if in rare situations, in some situations, we may have TAC in gold as well, but never below that.
Okay, makes sense. Okay, thank you.
Sure thing, yes. Okay, so I will move on now. So
Yes,
why did we want, yes, more question?
No, please, go for it.
Yeah, it's Norman here. I just wanted to add that the Cisco Beijing office is a gold office, right, Khalid?
Okay, thank you, Norman.
Okay, thanks.
That's good to know. For the local team, yes, it's a gold office. I think we have a TAC there as well, right, Norman?
Yes, I think so. Yes.
Yeah. Like I said, so we want to put TAC in platinum. So if your case goes to something in Brussels, that is a platinum. If some like in DGAM, if something goes to RTP, that is a campus. So again, so normally TAC is minimum gold. Okay, moving on. Why do we want to do SD-WAN? Well, for Cisco IT, our drivers are very much similar to what most customers are. We want to be able to do all these things with SD-WAN, which I am not saying that we cannot do without SD-WAN, but with SD-WAN, it becomes really easy. And because of the controller model, it is really, really simple and easy to deliver these use cases. So the biggest thing that SD-WAN brings to us is, and I like to call these features as the same. One is WAN optimization, application-aware routing. These two I like to normally bundle together. By WAN optimization, we mean, now if you were to think about the gold office that I talked about previously, where we have two links, we run EIGRP to the hub. And in most of the gold offices, normally we only use the L2 VPN. We do not use the DIA because most of the times this DIA is not equal bandwidth. We are trying to make it equal bandwidth now, but so for example, maybe the L2 VPN is 200 megabits, but the DIA is 150 or 100 or maybe less, or even if it is 200, it does not obviously give you any SLA. So there is no SLA guarantee on the DIA. And so therefore, with non-SD-WAN EIGRP routing, what we have done is we have sent everything only on the primary link. And so that now if the primary link fails, only then things will go on the backup, and the backup, which is DIA, and which means that our backup is not being used. And like I said, there are always ways to do these things without SD-WAN as well, but they're not necessarily the most intelligent ways of doing it. But with SD-WAN, when we turn a gold office into SD-WAN, we get the benefits of one, using application-aware routing, right? We can use application-aware routing here, and we can, in fact, make sure that our traffic, which requires SLA, like voice and like video, that they always go on the L2 VPN, right? And then we base this on DSCP marking because we are marking traffic on the edges. We are trusting traffic that is marked by our collaboration endpoints. So all our voice and video is having the right marking like EF or AF4X. And we are configured a policy where we say all such traffic must go through application aware routing over the L2 VPN link. Then there is the default traffic, which has a DSCP marking of 0. For such traffic, we say you can load share. You can send one flow on L2 VPN and you can send one flow on DIA. So that way, we are not keeping our DIA idle. It is being used. So we achieve the WAN optimization use case by using both links. But at the same time, because we are doing application-aware routing, we are doing intelligent traffic steering here and not just doing normal equal cost or some kind of variance based in EIGRP load sharing. So this is the first benefit that we are getting out of SD-WAN is WAN optimization and application-aware routing. The next big thing that Cisco IT identified as a use case and the benefit we are getting is network encryption. The information security department in Cisco requires that we encrypt both DIA transports as well as L2 VPN transports. So any tunnels or any traffic that has to go across the WAN must be encrypted. And so while you would normally, and we did encrypt everything that went over the internet, like in a site-to-site IPsec tunnel, we are not encrypting on L2 VPN, which is essentially a dedicated link. Now, when we bring SD-WAN to that office, then these get encrypted because we use IPsec encapsulation, and we don't have to do anything at all to get that encryption. Like we do not have to bother with pre-shared keys. We do not have to specifically enable the crypto maps or anything when you're doing site-to-site IPsec. It just encrypts everything, and it is a very easy and simple way of enabling that encryption. So if we did not do this otherwise, then there are other challenges when you want to do so many site-to-site. Obviously, we would not do, if we did not do SD-WAN, we wouldn't be doing so many point-to-point, site-to-site tunnels. We will have to do DMVPN, and then we have to do dual DMVPN cloud, and then we have to encrypt over top of that. So imagine the simplicity and ease of doing this when you're doing SD-WAN. I don't have to do anything now. I just say tunnel interface encapsulation IPsec, and it is encrypted using IPsec. Okay, so that is the second big benefit. The third big benefit that we are getting out of SD-WAN. Then there is the local internet app features, which is essentially what we know as cloud on-ramp for SaaS, which is what we want to target. But there's also cloud on-ramp for IaaS within SD-WAN, Viptel SD-WAN. And then there is the simple, raw, local breakout capability. Again, you may be able to do this without SD-WAN, but without SD-WAN, it becomes a little bit of a hack and is a little more complicated. But with SD-WAN, because we are using NBAR as the application recognition engine, the SD-WAN device can easily recognize traffic that has been approved by InfoSec for us, and that can be split tunneled locally at the branch to go to the public SaaS provider like Office 365 or iCloud or Box or Salesforce, whatever you want to have there, whatever application is recognized. So this is an application recognition engine, which means NBAR-based split tunneling is something that SD-WAN brings to us, which otherwise would not be easy to do. Finally, we have network configuration compliance. The way this use case has helped us is that because we are using controllers to configure provision, orchestrate everything, then all these devices are actually locked down configuration-wise to a template. And that allows us to meet the network configuration compliance demands that we have to be appropriately certified. Right? This also allows us, because we are controller-driven, it also allows us to do software version enforcement in our devices. So that is another major benefit that reduces operational downtime and increases the availability for our site by allowing us to meet the network configuration compliance requirements using SD-WAN. And finally, integration and scaling is something that is last on the list, but it is certainly something that allows us to, again, be quick in delivering services like day 0 and day 2, provisioning and management, because we can scale up very quickly. We can deploy lots of sites quickly because of the way the whole SD-WAN controller-driven provisioning and orchestration works. And also the integration piece where there is a big benefit if you are integrating your centralized service management tools into the vManage as opposed to pulling each device individually. So there are integration and scaling benefits that we see within the SD-WAN use cases as well. I am going to stop and ask if there are any questions about any of the use cases. No, okay. Let me move on to the next slide. So like I said, we have about 400 plus offices around the world, but of these, we are targeting approximately 300. Now, like I said, this number changes. It has changed because of COVID as well, and we are kind of reevaluating our office catalog all the time, but it is approximately 300-ish number that we are targeting to convert. We started this conversion process a while ago, but because we do not use the vEdge at all, we are only using ISR 4451 and ASR 1002HX everywhere, because we have all these offices have got these devices. Therefore, it has taken us a little longer to move to SD-WAN because we are waiting for all the features to be available in the cEdge for the SD-WAN deployment. Okay. Now, this is just a slide that is talking about the gold and silver offices where we are focused. I have a more detailed diagram later in the slide, but this deck, yes, we have a more detailed diagram in this deck. But what you see under gold is exactly what I told you. You have a branch office with 2 ISR 4451s with Cat 9Ks in the switch, and we build the SD-WAN overlay on top of the MPLS transport and the internet. I have more detailed slide going forward, and the same applies to silver. So this is how our gold office looks like without SD-WAN. You know, this is a very high-level topology that gives you the main features that we have configured there. And so this is not SD-WAN. We have 2 WAN gateways. One is on the left, one is on the right. And between these two, we have the primary L2 VPN, the green arrow, which terminates on the left one. And then we have the backup L2 VPN, backup IPsec over DIA. Sometimes in some sites, we also have L2 VPN as backup. Right? So this one comes over WAN gateway 2. Now, if the office is of the same bandwidth and they are both L2 VPN or both dedicated links, then we will do equal cost multipath for that particular office. Otherwise, we will not do any load sharing if the bandwidth is asymmetric. The L2 VPN, like I said, carries both IPv4 and IPv6. We are IPv6 enabled around the world. Every office campus in Cisco has got dual stack. We are IPv6 enabled, and so the L2 VPN is carrying both IPv4 v6 as well as voice and video. Now, if the primary fails, then obviously everything falls back to WAN gateway 2. Now, if this is a symmetric site, which means both links are same bandwidth, then no problem. Everything comes over to the right-hand side. But if this is a asymmetric site, which means the backup bandwidth is less than the primary bandwidth, then we have a configuration where we block signaling for voice. And that means any voice calls are now using SRST, which means the WAN gateway 2 here. This one also has voice modules, E1, T1 modules, with local breakout to the PSTN. So if the primary link goes down for an asymmetric site, we use the backup link just for critical services, and all voice services will fall out to WAN gateway 2 through the local PSTN using the voice gateway features, SRST, and the video endpoints will not really be guaranteed any SLA over backup, unless this is a symmetric office. So this is how our non-SD-WAN office kind of provided services and SLAs. Now, when we go to SD-WAN, how did we migrate? What did we do? But we'll talk about that. But mainly, when we move to SD-WAN, then we have got this situation that I'm showing you now. In the initial phase 1, we converted, and we did phase 1 about 1.5 years ago now, right? We started 1.5 years before. We did some sites, and then COVID came up, and all the offices kind of went into lockdown, and we had to stop deployment. But yeah, I'll talk about that a little later. But how did we do this 1.5 years ago? In order to do zero-touch provisioning, we configured SD-WAN on the left-hand gateway, the one which is terminating the L2 VPN. So now, for the branch office here, and there's a reason why we did this, and I'll explain those reasons. We have in a gold office one gateway which is doing SD-WAN and one which is not doing SD-WAN. So the reason we kept this one without SD-WAN is because of voice module support. So voice module support only came out, I think, in August or September sometime. And we had already started deploying by that time. So remember, if the primary goes down, we need to use the voice module for SRST and local PSTN breakout. So because there was no voice module support, we did not do SD-WAN on WAN Gateway 2, which has our voice modules. Also, IPv6 was not supported 1.5 years ago on the service side. It only came later. And so because we are dual stacked, IPv6 from the office would follow the site-to-site IPsec tunnel, basically the underlay, and will continue to work even when we turn on SD-WAN for IPv4 there. So these are the two main reasons why we did not convert both gateways to SD-WAN. However, now there is voice module support, and there is also IPv6 support on service side for SD-WAN. So the next phase is converting everything to SD-WAN. So we are working on that now. Now in this particular SD-WAN office, what is happening is we have from SD-WAN GW1, from the left device, we have one BFD session, two BFD sessions actually going over L2 VPN, private one, the green arrow, and we have two BFD sessions going across this lateral link through WAN Gateway 2 as biz internet BFD sessions. And we are getting full SD-WAN use cases that we wanted out of this office by deploying this one SD-WAN gateway even without doing both of them on SD-WAN. So we are able to get WAN optimization. We are able to get application-aware routing. We are able to get network configuration and compliance, integration and scaling. We are able to get encryption, and we are also able to get any local application breakout. Though I must say we did not configure it because, again, 1.5 years ago, there is no cloud on-ramp for Office 365 on C Edge. Today it is there, but 1.5 years ago, there is not there. So in phase 2, all these things like cloud on-ramp for Office 365 and the local internet breakout will be available. Moving on, so this is the phase 2 part where both devices in the Gold Office will be SD-WAN enabled. We will use a TLOC extension to extend the L2 VPN towards the right-hand side SD-WAN gateway, and we will be doing, again, the same use case as we did before. We will do dual stack, we will do voice video, which will go over L2 VPN. We will do DSCP0, which will get load shared across both. Yeah, that will meet all our SD-WAN use cases as well. Okay, now why did we do this iterative approach? Why did we break down the deployment? So a couple of things that have influenced this is the exposure and experience. All the operational teams inside Cisco IT who have to configure and manage this network, they must be trained. And if we go and turn everything into SD-WAN in 1 week, we will have a lot of problem finding the skill set to support these devices. So as we go slowly, we allow people to be trained so that they know through education, through exposure, and through experience, they understand the technology and are able to support the infrastructure appropriately. The iterative approach that we have adopted also allows us to, develop gradually the common infrastructure. I'll talk more about this point when I'm going to talk about the migration-friendly hub design, okay? But right now, because we are not doing everything in one instant, we can slowly develop the common and core infrastructure. I'll talk about that in another slide coming up. What I mean by flexibility and maturity through retrospection is that, look, if I do 2 sites and then I monitor those sites and then I learn from those sites, then when I go and do the next 2 sites, I will have learned something, and maybe those 2 sites I can do better. And this is what we experienced. When we do this site by site by site, we improved and matured our migration process and the way we migrated these sites. So that is what I mean by flexibility and maturity through retrospection. Every time we do a site, if there are some mistakes, we do a retrospective on that. Then when we go and do the next 2 sites or 3 sites or 1 site or whatever, we are now more informed, more knowledgeable, we have more experience, and we change the process so that it becomes more efficient and is more accurate. Finally, everything we do inside Cisco network services is in an agile manner. So by breaking down the large office migration into smaller chunks, we can align very nicely with the agile processes that we have adopted in delivering these services. One of the big things that we have used in deploying phase 1 of SD-WAN with C edges, like I said, we are only C edges everywhere, is the use of automation. So we used zero-touch provisioning and automation to deliver these sites in a turnkey manner. And I'll tell you how we did that. But before I go into that, let me go back to a previous comment I made about a lesson that we learned around DIA. So I told you that the type of internet connection we have inside an office is not cable modem or DSL. We have a direct internet access, dedicated last mile into the POP coming from a tier 1 provider. Now, while that is offering you no congestion on the last mile, it does come with one problem. Most service providers will not give you DHCP on such DIA connections. So you will not be able to get DHCP. You will have a static address. Now, that is one problem when you're trying to do zero-touch provisioning. If you cannot get an address through DHCP, then you will not be able to initiate the zero-touch process. And therefore, we saw that the phase 1 SD-WAN deployment method, where we are only using the left-hand side, ISR 4451, this one here to do SD-WAN, and the other one is not being used, that allowed us to deliver DHCP-based address assignment to the green router here from the blue one, because the blue one is normal IOSXE. So what we could do is we configured a local DHCP server on WAN gateway 2, this one, which is not going to SD-WAN. And while we did that, it continued to work. There, we didn't have to have any downtime for that or anything. We just configured a local DHCP server, which would serve an IP address to the SD-WAN gateway. And that is the thing that really allowed us to do the zero-touch provisioning by a simple click of initiating a script, really, if you want to say that. Because then the SD-WAN gateway here, we already have it onboarded in PNP Connect. We have the configuration in the SD-WAN controllers, which are in the cloud. We already have the device attached to a template on the vManage. So the only thing we need now is for this one to give it an IP address. So we basically erase everything on SD-WAN gateway 1, make it the default factory configuration with IOSXE SD-WAN image. We reboot, it starts up, it gets the IP address from WAN gateway 2, it goes to PNP Connect, identifies the vBond. Everything else after that happens automatically following the zero-touch provision mechanism. And it comes up with the 4 BFD sessions, 2 going over L2 VPN primary, because we have redundant aggregation points in the hub. So we'll have 2 going up for L2 VPN and 2 going over this for Biz Internet. And so, again, you know, if you think about it, because we are doing it iteratively, step by step, the migration becomes easier because we can do zero-touch provisioning with DHCP leveraging the other device. But again, it doesn't mean that we wouldn't be able to do nearly zero-touch. We can still do that if we were to use a bootstrap image. That is what, sorry, a bootstrap config file. So that is what we are going to do in the next phase, where we are going to convert both devices to SD-WAN, right? In this particular case, we are going to use a bootstrap file for SD-WAN gateway 2, again, which is already pre-created in the vManage. And because we already have access to the site through SD-WAN gateway 1, we can just put the bootstrap file in the config, reset, reload, and it will come up as SD-WAN. So that step-by-step migration approach has its benefits in converting sites gradually. And I'll show you the hub side benefits as well. Now I'm going to go to the hub build out, but before I go there, can I stop and ask if there are any questions?
请问大家有没有问题？请问大家有没有问题？ I think they have no questions in this moment.
Okay, thank you.
Okay.
Okay, so how did we do the hub design? So when we did the hub design, imagine I told you we are an office, we are a large enterprise, and we've got these 17 hub locations where we have got L2 VPN aggregation on 10 gig interfaces, right? So if I have, like, let me give you the example of London, where I live and work. So if I have my L2 VPN 10 gig aggregation in London, and I want to convert one office to SD-WAN, then how do I separate the L2 VPN from the aggregation? Do I put another device there which has another L2 VPN aggregation of 10 gig or 1 gig, and then move this VLAN over to that one? It becomes expensive. It becomes time-consuming, and I don't want to deploy more devices or get more WAN links when I want to migrate. So that is the reason why we developed this hub design, which allows us to migrate our SD-WAN sites at whatever speed we are comfortable doing it. We don't have to do everything in one night. We can do one site at one time, and we will not impact any business operations, any services on that site at all. So the hub design, which is currently deployed across our hubs and is in production, was designed keeping that big migration thing in mind, right? That we don't want to spend money on extra WAN links, and we don't want to spend money on extra interface cards or devices. Right? Let me tell you how that works. So if you look at the old non-SD-WAN network, then this is how it is. We have a regional hub over here, which is non-SD-WAN, which connects to the core. And we terminate all our connections on the ASR 1006. So every hub has two ASR 1006s, which have got different kinds of interfaces. You've got channelized, you've got Ethernet, you've got OC. You've got all sorts of interfaces on these which connect to the branch offices depending on the amount of bandwidth you need to provision to those branch offices. And like I said, imagine that this is a branch. It is running a gold office. It will have one link to one ASR 1006 and the backup link going through internet, site-to-site IPsec, coming to the other ASR 1006. So we have WAN redundancy with two WAN transports coming in, and then we have device redundancy. If one ASR 1006 fails, the other one takes over, right? So this is how our non-SD-WAN network is created. Now, when we move to SD-WAN, the idea is we are going to use the non-SD-WAN network as an underlay, right? Because we have IP connectivity. So the approach was we put two ASR 1002HX right next to the ASR 1006, and these two will do the SD-WAN aggregation, right? We have to do this anyway because the ASR 1006 does not support SD-WAN, right? So we did not do this because we want to deploy another device to bring SD-WAN, but the fact that SD-WAN aggregation or SD-WAN is only supported by the 1002HX. So we had to get these devices anyway, right? And then we connect one 10 gig interface between these two on both sides. On that 10 gig interface, we have got sub-interfaces. One is the service sub-interface, and then we have got also the transport sub-interface, which is connected between this. So you have one 10 gig interface, but then you have sub-interfaces, which are different. One is service, then you have one transport as private one is private two, one is biz internet. And that way, what we have done really is we have provisioned the aggregation devices for SD-WAN. They will learn of all the underlay routes from the core through the service interface here, and we are doing some tagging, so we don't do any unintentional route redistribution, because we are learning them from both sides. Because of redundancy, we are learning on the left and we are learning on the right. So we tag and we filter and everything. But the idea is we are learning of all the core and underlay routes through the service interface. And then when we want to migrate a branch to SD-WAN, we just move that branch over to SD-WAN, like I told you in the previous slide, and it establishes a private WAN biz internet tunnel to this one using the existing underlay, and a biz internet tunnel towards the right using the existing underlay as well. So every gold office SD-WAN gateway, like I showed you in the previous slide, will have two private WAN tunnels, one coming to this one and one coming to the right-hand side. It will have two biz internet tunnels, one coming to each ASR 1002HX. Now, this is a very simplified diagram. In fact, to do this, we did have to do a lot of route tagging, a lot of route filtering to make sure that the appropriate routes were advertised accordingly. But what this allowed us to do was we can migrate one branch, second branch. If we want to do, we can do 20 in one night. If we want, we can do 1 in one night, and it will not impact anything for that other branches or for that branch. It will be very simple to migrate step by step. Okay, so moving on, how does the inter-hub routing work? So imagine this is San Jose. In San Jose, like I said, we have got all these branches, and then we have the two legacy ASR 1006, and we have the ASR 1002, and we build the overlay for this hub over here. Now, if any traffic has to go from the branch to the data center somewhere over here, or if it has to go to another branch, then it goes through the overlay, comes out of the aggregation, and it goes into the underlay, which connects the global backbone. And that is how things are moving from one hub to other hub, from one branch to another data center, and from one branch out to the internet or wherever, right? Each of these hubs, they also advertise summaries into the core. So that is one reason why we are not full mesh, because we are physical hub spoke. We have to remain logical hub spoke in the overlay as well. And we cannot have one branch from this region connect a tunnel into this region, because it does not belong to this summary. So this is some constraint we have in the topology policy configuration we have on the vManage when we configure those things there. So all the San Jose branches, they must only form a BFD tunnel to the San Jose SD-WAN aggregation. They cannot form it to RTP. And like RTP cannot form it to San Jose, mainly because of our summaries, these summaries here, and this one. Okay, so moving on to the next slide, I also want to call out that we have got, like I said, we have got about 17 hubs across the globe, but we also have 3 overlays. Our overlay in Asia Pacific, which China, Hong Kong, Taiwan, Australia, all these places, is having one set of controllers. Our overlay in the US is having one set of controllers, and our overlay in the Europe, Middle East, and African region is having a separate set of controllers. So we have 3 global overlays that we are using across the world. So I'm going to talk about a few of the lessons that we learned as we were deploying that. The first lesson that is very important for us is standardization. So when you are a brownfield relocation, which means you're not doing new offices, you already have existing offices which you want to migrate, then if you have different configurations in the offices and you are not standard, then there is a big problem. Then you cannot create common templates for these. And so it is very important that a brownfield migration be standardized. Because we are using DSCP0, application marking is also very important. If we don't mark the applications properly, application-aware routing is going to fail. You're going to put latency sensitive or voice and video on biz internet, which does not have guaranteed SLA, and that is going to impact user experience. If we are DIA bandwidth sizing and user experience, if we are going to load share traffic, which is marked as DSCP0, and we are sending, let's say, one flow on L2 VPN and one flow on the DIA, we must make sure that the DIA has enough bandwidth to support these users. Because there is loss, there is congestion on DIA circuits, you don't want to have a very small DIA bandwidth, which is going to impact user experience as well. We also had to revisit or redesign our QoS for SD-WAN sites. And there are many factors that have caused us to do that, but the most important ones are related to application-aware routing. Because we are putting all the voice and video on L2 VPN, but we are not putting all the DSCP0 traffic on L2 VPN, we have some more space on L2 VPN for voice video. Likewise, because we are not going to put voice video on the DIA, we can then have more space for default queue traffic or DSCP0 traffic on the biz internet. Therefore, we have to go back and revisit our QoS configurations so that we can adjust the queue sizes according to the new application-aware routing policy. We also found some issues around MTU. So what we have done here is we have disabled path MTU discovery, and all the MTU for our service interface is set to 1438. And you know, maybe once at the end of I can go into more details about this, but for us, we don't want to do path MTU discovery, and we want to lock down MTU to 1438 on the service interfaces. And then finally, there's the manual versus automation and DHCP issues. I think I already talked about the unavailability of DHCP on DIA circuits. So we've already talked about this. Some lessons around the design and policy piece is that because we are hub and spoke on the physical topology, we also created hub and spoke logically. It is a default, it is full mesh by default, so you must make sure that you configure the right topology. It is also very important for hub and spoke that your spokes establish the tunnels to your regional hubs, especially if you're doing the summaries. Otherwise, you can establish a backdoor from one hub to another hub and actually end up causing routing problems and blackholing traffic. So this is a very, very important consideration that you must have when you are designing your SD-WAN overlay. The learning curve is very steep for SD-WAN, and I think you must have seen this yourself. So we have our operational teams go through lots of trainings. So like the lead engineers like myself, Norman, and everybody, we whenever we do something, we share that with the wider team. They've gone through partner instructor-led training. They've gone through video on demand. They've gone through TOI, transfer of information sessions, and knowledge transfer sessions from us. So there is a lot of training that is required for people to understand how SD-WAN works, because it is very different from the normal network. Finally, there is the feature parity and the DSCP piece. Now, when you are moving to template, you may not be able to do everything in templates. That has to be specifically configured or supported in the template if you want to move to template. Otherwise, you will not be able to move to template and you will be in CLI. Now, if you are in CLI, then what happens? I lose the network configuration compliance portion of my use case. It doesn't mean you can't do SD-WAN. You can do SD-WAN, but you will not maybe able to do any network enforcement or configuration compliance enforcement. So that is something we have to, and then the feature support in templates is changing every day. They're adding more and more features into templates, but you have to be careful about what features you have deployed or are planning to deploy are supported in templates. Finally, I talked about DSCP markings, and the one thing that we saw is that, okay, so maybe sometime applications are not marked properly in DSCP. Then we can use DPI to still capture those applications and give them the right SLA. So this brings me to the end of today's session. I am going to top this off by a quick, I'll show you the production vManage that we are using to the extent I can. And once I've done that demo, then I will open for question and answers.
Okay.
Cool. That's good.
Thank you very much. Yeah, thank you.
Sure thing. Yeah.
等一下，我们的同事会将这个production 的 environment 给大家看一看。如果看过之后，如果之前的 presentation 啊，可能中间有问题的话，然后就可以在这个 chatbot 里边问。如果真的有问题，可以在这个 demo 之后啊，就再问我们的 presenter 吧。啊，谢谢你们。好。You can go ahead. Thank you.
Yes, I am just doing that now.
Okay.
Okay, so so what you're seeing here is the GUI for our European controller, right? And you can see that I don't know how familiar you are with this, but you can see that we have got our 2 vSmarts, 2 vBonds, 1 vManage. We have 23 WAN edge devices that are currently up and operational. We have, I know that there are 2 sites which are having 1 link that is failing. That is why we have partial WAN connectivity on 2 sites. We have full WAN connectivity on 19 sites. And then it gives you a couple of other high-level information. Gives you the application, what are the top applications. It gives you the transport health. It gives you the latency loss and jitter across your the highest latency sites. I don't know why these portlets are not working, but yeah, sometimes this happens. But it's not a problem with the vManage. I think it's a problem with my browser. I'm right now having some problems with this. Let me see if I can. Okay, so just to quickly show you, let me show you application-aware routing, for example. I can go to network, and when I go to network, it gives me a list of devices that I can monitor. So I can, for example, go to, I don't know, maybe this device, which is Ecublens in Switzerland. And I can see on this device various information about that device. I can go and look at, tunnel, and it will tell me how much loss I am seeing on the various tunnels, because like I said, we have 4 tunnels. 2 private ones and 2 biz internets on each device. I can go to applications, DPI applications. It will tell me the different kind of applications I have that are going across this. I can maybe go into one of them. Now remember, we have a work from home policy mandatory right now. Nobody is pretty much in the office. So the traffic you're seeing is people who are sitting at home and trying to access labs in their office. So you may not see a lot of traffic that is showing here in that sense, but I'll see what I can take out. So see, there's oops, there was. So if I go to web, then just trying to see if I can show you some. No format. So HTTP traffic is normally something that is load shared. So I don't know who this is, but you can see that we have pretty much half and half distribution that is going out of this office. Half is going on biz internet and half is going on private one. This is this one. Likewise, like I said, because there are not many offices, not many users in the office, so it's a bit difficult to show a lot of the traffic here. But let me see if I can find some voice video traffic. Very little. So this is Cisco Spark, which is also the WebEx board. So you can see that a lot of their traffic is going over private one, but it also uses a lot of DNS traffic and other management traffic, which is going out on biz internet. I think there is a Cisco Spark video that I saw here. There is this one. Yeah, so you can see that all the video traffic is only going out on private one, and there is nothing going on the biz internet. So this shows you the policy that we have configured, that we want all the voice video to only go on private one, which is the name of the BFD session that is established over L2 VPN. And then I can kind of go back to the main dashboard. And then, we could extend the session, but well, I mean, it becomes too deep. But when we go into policies, that is the centralized policy that has been configured, and then you can go into traffic policies, and I can just show you, very quickly the application of aware routing policy. Okay, so this is the application aware routing policy that we have configured. So there are some things there, but you can see DSCP 32 to 46, which is all the voice video. That is configured that it goes out as a preferred color is private one. And then if the private one is not available, then it will go on biz internet or private two. So and you can see here that we have DSCP 0, which is the default traffic, and that is preferred color is private one, biz internet, private two, which means we will load share across all these transports for DSCP 0 traffic. Okay, I think that's all I can share on this. I have to be careful in not going too deep, because then the IP addresses are exposed and everything. So the information security guide says just keep it high level.
Okay.
Okay, thanks, Halid.
You're right. Yeah, thanks.
Okay, now if you have any questions, I am happy to answer them.
OK， 请问大家有没有问题啊？请问大家，香港的 PALA 还有台湾国内的，请问有没有问题？
对，大家想一下，思科一共有3400个 router 哈，然后前面讲到有19个 hub， 然后有480个 office 都要迁到SD-WAN 上面啊，所以你可以想象到有很多的问题哈，有很多的 challenge。那哈利的是我们的 IT manager， 他其实不管需要考虑到网络，也需要考虑到这么多应用有这么多的客户还有员工，还有供应商都需要访问到 Cisco 的这个网络哈，所以 所以大家有任何您觉得就可能你觉得有可能关心的一些问题，或者可能相关的一些问题啊，其实都可以问他Khalid。Okay, Khalid, I got two questions. The one is I'm curious about for example in Shanghai, we have a DIA right in SD1, but if we access 0365, when the internet traffic crossing China border, there will be some impact by the Great Firewall. So could you share some of the how we handling this kind of issue? We reroute to the private link or some kinds of the policy to support we using the SD1 optimize the QoE, especially for the SaaS or 0365.
Okay, so if I was to repeat your question, I think you're asking, what is the impact of the Great Firewall in China on Office 365 Cloud on-ramp?
Yeah.
Right.
Yeah.
Okay. Cisco information security requires us that we do not do any local breakout in China. In fact, if you were to go to the internet from a Cisco office in China, you will be going out of Hong Kong. Mm-hmm. So we don't have local outbound allowed in China at all. Mm-hmm. So I'm afraid we will not be able to do cloud on-ramp for Office 365 in China.
Okay.
I don't know how the sales teams are positioning this for customers in China.
Mm-hmm.
I'm afraid I don't have that knowledge. We do have inbound VPN termination in China, but mm-hmm. that is only for inbound. So if you are in a Cisco IT office in China and you want to do your SD-WAN tunnel from local internet, it will go from the office and it will come to our hub in Shanghai.
Mm-hmm. Yep.
It will not go to Hong Kong. That's all we do. Inbound termination is possible for us in China, but we don't do any local breakout in China.
Mm-hmm. Okay, got it. Thanks. And another question about I see you shared lots of the impact about the application and the IP address, and also there's IPv6 or IPv4 and the routing distribution. So could you share some what do you think? What kind of the biggest impact for the current network migration with or coexisting with SD1? What's the biggest challenge, and what is the best benefit when we have the SD1, and what do you that's the two kinds of a question. What is the biggest impact and for current network, and what is the best benefit?
Okay. So just to make sure I understand your question properly, you're saying that if you have an existing network, what is the biggest migration challenge? That is one part. And the other part is what is the best benefit that you see for an existing network? Is that right?
Yeah, that's right.
Okay, in my personal experience, when I did this, both on the designing and the deployment side, I think the biggest challenge when you have migrating a network is feature support and your ability to design around that, right? And I'll tell you the story. I've already told you to an extent, but the story around that when we talk about Cisco is when we were told that, because every time there is a new technology we are trying to sell to the customers, we are told that we must put it in our network, right? So we have with SD-WAN, we must deploy it on all the network, and so we have to show to the sales team, to the partners, to the customers that yes, we have successfully deployed it. However, 1.5 years ago, when they told us to do it, we said, okay, well, big problem is we don't have the full feature support, like the voice module is not supported, like IPv6 is not supported. So then, the challenge in my mind comes up to design a network which allows you to deliver the new technology benefits while at the same time making sure that you are backward compatible with what you have in the service as services in the office anyway, right? And so the designing of the gold office so that you have SD-WAN on one gateway, but you don't have SD-WAN on another gateway was kind of a challenge we overcame by design. Another challenge in a similar situation was how do you move the big 10 gig L2 VPN aggregation circuit without paying extra money? Again, so the hub design was created to overcome that limitation and allow us to be able to migrate slowly. Because in all honesty, the ASR 1002HX did not support a lot of aggregation features 1.5 years ago. And even if you do that, then there are routing considerations that you have to look at, especially when you are trying to do L2 VPN. So in my mind, the biggest challenge when you're migrating a brownfield network is your ability to design around the lack of feature support and make sure that backward compatibility is there when you do that design.
Yeah.
What's the benefit? I already took, if we didn't do SD-WAN, then I know that I'll be working on dual DMVPN cloud for 17 hubs with encryption, because information security department had told us you better start encrypting everything. And then that means we have to deploy a whole new DMVPN based encrypted dual DMVPN clouds everywhere in all of these hubs, which is a big project, big change. So to me, one of the big benefits in terms of saving my time and saving a lot of that time is the encryption that comes very easily with SD-WAN. And then of course, that is not the only benefit. The other big benefit is around the ability to optimize WAN, right? So we are becoming, having a lot of WAN efficiency. A lot of the applications are getting the SLA. And more importantly, I see that SD-WAN failover, and I've tested this, is, for example, maybe I will lose 1 or 2 ping packets when SD-WAN fails between links. So the SD-WAN failover is very, very quick because of the way the whole overlay technology works. So there are lots of benefits when you say, what are the best benefits that I got? I can't say one. There are at least 4 or 5 benefits that I see with SD-WAN over a regular network. I hope that answers the question.
Yeah, it is. Thanks a lot.
Sure, thank you.
哎，Ray， 你有没有问题？或大家有没有问题？
我应该没有嘞。对啊，然后就他吧。对啊。Hey, thank you very much. Yeah, it's a very good sharing, and then we have learned some much of from your side. Yeah.
Okay, well, thank you very much for giving me a chance.
Do you is it possible to share your deck with our partners?
Yes, absolutely. You can share this deck with the partners. It is there in the space as well.
Okay. Thank you.
Thank you very much.
Okay.
So 白涛，你出来 closing 吧。